what is your mass at the surface of a planet twice as massive as the Earth but having the same radius? Okay? So like the effect of different quantities on quantities that we deal with. Of course, you see this first one here is a little of a trick question. It is asking us, what is your mass? Hopefully, your mass is the same no matter where you are. So mass, no change. Mass is not affected by the gravitational field. Mass is a measure of the amount of matter, and that's the same anywhere an object is. Now, what about your weight? The weight is a different story. Now, for weight, now since they tell us of a planet that's different than the Earth in terms of size, we cannot use just mg. So what we are going to do is compare both equations. The gravitational force on Earth is given by g, your mass of Earth over radius of Earth squared. The expression on another planet, I'm going to just write P, it's going to be G, your mass of the planet over radius of the planet squared. Now here, what do they tell us? They tell us that this planet is twice as massive as the Earth, but having the same radius. So what does that say? It says that this is the same. Of course, we know that G is the same. And we know that your mass is the same. So what's the only thing changing? MP is twice as big as MR. If everything is the same and I double this, what would I get? I get an FP that's twice as much as this. So in other words, F on the planet is twice as much as F on the Earth. Okay? Let's try another one. What is your weight at the surface of a planet? This time it is as massive as the Earth, but having twice the radius. Okay, we are reversing it here. Okay, so I'm going to write just Fe this time. The gravitational force on the Earth is G mass, your mass of the Earth over radius of the Earth squared. And here, F on the planet is going to be G, your mass of the planet over radius of the planet squared. Now, what do they say? They say the mass is the same, which means this is the same, this is the same, and this is the same, which means all of this is the same in both equations. So what's going to change? Instead of RE, I have twice RE in here. Okay, let's try to implement that. So I'm not going to write everything. I'm going to just put a symbol to what's the same. And here instead of RE, I'm going to have twice RE squared. So that's going to be equal to whatever is the same over twice squared times RE squared, which is whatever is the same over 4RE squared. But what's RE squared? That's here. So whatever is the same became bigger now. This is what's the same now. And I'm left with 1/4 whatever is the same. So what does that tell me? Now, if I have a less dense planet having the same mass but twice the radius, I'm going to feel a lesser gravitational force. In this particular case, it's a fourth as much. Okay, we are done with the definition of with the recording about gravity.